Yes.
Remember, I don't know if you remember now, but I asked about constants on Piazza. There was one question I held up that was actually asked. If you have two classes of the same name, did you make a constant from them?
I'm sorry, if you have two classes of the same what?
If two classes have the exact same name, but they're in both the default package,
You cannot have two classes with the same name in the same package.
oh, then what happens on that graph if they're making different projects that have the same other projects?
That would be bad if in the submission I did not give them different names. You,
Well, not the submission, I meant like in different projects, NetBrand have different versions of Bug 2 or Word 1 or Word 2. Those are all named the same for different.
oh, but they were never compiled at the same time. So if you make 5 submissions, they don't get put in the same pot.
Yeah, I mean, I was talking about calling from that class a constant. Like if I was to call a constant from a word class, how do I know that it's going to go to the right one?
You have to put it in. I mean, the way NetBrat works is whatever it is that you submit. So
So if I wanted to call a constant from another class,
yeah. So let's say over here I have a rectangle and I have a tester. I don't remember what they do, but we had them last time. So over here in the tester, I could put a constant.
right, and it's just called tester, but there's like a bunch of different classes called tester.
You can't have more than one class called tester. Not in the same package.
I know, but you said that all of our stuff that we're doing on BlueJ goes into the same default.
No. It goes into the default package, but you have different projects that are unrelated to each other. So every directory that you make in BlueJ is a different project. Those projects have zero connection with each other. You would not be able to take a constant that you defined in one project and use them in a different project.
Oh, so it has to be in the same package.
Yes. Yes.
I didn't know that.
Yes. So they're all, like I'm going to make a new one here right now for today's lecture. So, or let's say for one of the homeworks. So when I say project, new project, here you see all these other projects. They're all completely isolated from one another.
There's no way you could possibly access
No, there's absolutely no way. And that's by design. If you wanted to have a more complicated set of shared code with like subdirectories, you would use packages. And we haven't talked about packages yet. Okay, other questions?
kind of stuck on a 9C.
All right, so that was more of a statement than a question. 9C final. Let's see where do I have these homeworks here.
I've gotten away with not using arrays for the entire assignment of 9C.
So what are we supposed to do? We're supposed to return.
Substrings is fine for the longest repeated.
So you want me to talk about longest repeated substring. Let's get out some graph paper. So we're talking about longest repeated substring. So the question is, we want to find some string that exists elsewhere in exactly the same way.
My idea was to start finding the largest substrings first, so that you could get your largest match right away. And just stop.
All right, so let's first of all back up a bit and see if you have a particular substring. That substring would presumably be defined by it has a start and it has an end. And so you have the substring, and you may have in fact extracted it. And then now you're hunting for a duplicate of it. How are you going to be able to find the duplicate? So there are two ways of doing it. The tedious one would be to, also extract all the other substrings that you can think of and call equals to see whether they're the same. The easier way of doing it is to use, is index off? I believe it's called index. Did I give a hint? No. Let me pull up the string API. Oh, you certainly wouldn't have to compare character by character, because if you extracted the other substring, you could call equals on them. But there are other methods that should be able to help us, and the particular one that I had in mind is index off, an awfully useful method that gives you the index of a substring. So let's try that out real quick here. What's today? Lecture 18. So we could find out where the string exists, for example, and it says there is one that starts at offset 1, and that makes sense, right? So let's try another one. And it says the string sip is there at offset 6. That would be, is it? I want a string in there. I'm just not buying the 6 right now.
That's correct.
0, 1, 2, 3, 4. Well, it is correct though. Okay. Yeah. Okay. So that's, on the other hand, is not entirely what we need, because let's say we found the string is, and now we want to know whether it occurs in there again. Let's see. Aha, but there is a second index off method that is willing to take a from index. So that's where the search should start. So now when I know that, let's say over here, I know that is occurred at index 1, and now I want to check whether is occurs again. Then I can start after the 1. So I have a starting position here. Which starting position should I take? They shouldn't overlap, so I should look at the end of the first string. I should take the position where it occurs, add its length, and then start there. Right? It was too long. And that's a mistake that some people made. I saw a bunch of people whose count was off, and then when in Piazza, and then when I looked at it, it appeared that they were not doing the non-overlapping one. So it can sometimes happen. Let's see if I can find an example here. Yes, for example, if you look at the string issy. So the string issy occurs here, and then it also occurs here, but we're not counting that in this particular homework, because I arbitrarily said that I only want the non-overlapping repetitions. There's no particular reason I said that one. I could have set it up the other way around, but that's the rule for this homework. So you have to be careful to add the length to that. Let's try it with another one. So we found sip at position 6. So when we try that again, I would have to start at position 9 because SIP is 3 characters long. And then it says -1, so SIP didn't repeat. Yes?
So in that first variable, in that first parameter, you have to put a string, or can you put like a string variable?
No, it can be a string variable. It has to be in a reference to an object of type string. Whether it's a variable or a fixed string is immaterial.
Right, yeah, because I mean, we're not going to know exactly what the string is.
No, no. And so that brings me to my next question. So if you had already had a particular string, you could now use substring, and then you could use index of. Sub and what we just discussed, like start plus length or some such thing. And so the combination of these two would enable you to find out whether the string was repeated. Remember that index of returns a -1 if it wasn't found, and that would be the indication that it wasn't repeated. If it returns anything other than a -1, then we would have found a repetition. Well, that's if we had the bright idea of using this particular start and end. So it looks like what we really need to do is we need to figure out how to be able to extract all substrings of a given string. And then we could try for each and every one of those substrings, we could try this recipe and see whether that particular one was repeated. So how do we find all substrings? That is, in fact, the first part of the assignment.
Yeah, when you would just set up a counter on that,
So here this assignment actually cleverly asks to find all substrings of a given length. So let's have a look at that. So I have a string, and now I want to find all substrings of length 4, say. Why do I say length 4? In general, it's a good idea when you bang your head against a problem that you try to come up with some typical, more concrete value. I could explain it to you and say all substrings of length k, but most people find it easier to deal with a typical value, and 4 seems as good as anything. Yes?
well, I was going to go for like text dot length divided by 2.
Uh,
For substring, and just work my way down.
Okay, right now what I want to go a step back and explain how one can locate all the substrings. And then your idea is absolutely correct to do them in decreasing order. But let me first of all get back to this, because it's not clear to me that everyone knows how to do this. So how do we find all substrings of length 4? Well, it's easy enough to find the first substring of length 4. That's the one here, right? And what's the next one? Well, that's going to be this one here. And what's the last one? That's going to be the one that goes, all the way down like this. And so now you can see how many of them there are. There are, if this thing here has length n, there are, not quite n of them,
N minus 2.
or n minus 3, or some such thing. So that probably means that one can print out all substrings of length 4 in a single loop. If there had been like n squared or n times n minus 1 over 2 or some such thing, then one probably would have needed 2 loops to print them all. But if there's just n of them, chances are you can just start, print from 0 to 3, from 1 to 4, from 2 to 5, 3 to 6, and so on. So let's just simply write this loop here. Let me get my... Oh, it's not giving me the file? Oh, not nice. I guess I can just write it. This is word 3. Yeah. So I'll just print all substrings of length 4 for right now. So I know that my starting index starts at 0. I'm not quite sure when to end yet. And it's text dot substring. I start at start and I end at start plus 4. And then I'll print it. All right. So then where do I end? Well, one way of figuring it out is that when at the very last one, I want start plus 4 to be what? That's my picture here. So this one here would be start plus 4, and I would want it to be the number of characters in the string. So that means start plus 4 is what is it? String dot length, text dot length. Text dot length. And that is the last one that I still want to do, or is it? Well, I'm wondering whether that's the one that I still want or not. So yeah, so I would subtract 4 now, and so then it should be start less than text dot length minus 4. But from the reasoning that I just had, it would seem to me that it should be less equal because I still want that one. Well, that's what the force of logic tells us. Let's see what happens. So here's my try so far. Let's compile it, make an instance of it. Oh, because I quotes. And let's call this method. Okay, and that looks pretty good. Right, and it did print the very last one, so I was right about the less equal. Now, why do I do it like this? There was nothing in the homework assignment that says you're supposed to do this for length 4. It said to do it for a general length. So it seems like, you know, I'm wasting my time here. This is not something that I asked for. But in general, I find it helpful when I deal with a complex problem where I don't quite know the solution to first come up with something that's a little simpler, that I'm pretty sure I can do, and that likely is going to have a pathway to the right solution. And the reason for that is that when this stuff kind of works, and I look at this output, I'm happy. Right? Because that's one of the great things about programming is you do something, it's a little non-obvious, you check it out, it works, and you get this instant feedback that you were on the right track. And you want to make use of that fact. If you try to solve the hard thing right away, and it takes a long time, it can be frustrating. And it's frustrating for me when I do something that's not obvious. And I've long learned to break down everything that I do into chunks where each individual chunk is relatively easy and brings me some amount of happiness. Because then as I work through my day, you know, some stuff works a little better, works even better, and before I know it, I'm done and I had fun doing it. If on the other hand, I try to do the hard thing right from the beginning, then I know I'm going to get frustrated, I'm going to punch my fist into the monitor, and it's not at all a good way of spending the day. So it really is a good idea to come up with a problem that gets you on the right track. And really, now I know how to do it with length 4. Now how hard can it be to replace the 4 by an arbitrary number, right? So now my first guess is to be, can I put an n every time I saw a 4? And more likely than not, I can. Well, n is passed as a parameter. It's not going to change. So that was easy. Let's see if it works. Let's print all substrings of length 6. That looks pretty good. Okay, so now I know how to print all substrings, but of course that was not what the assignment asked me to do. It asks me to try out something else with all substrings. And it did, and also it asks me to do it for all lengths. So let me make something that's somewhat on the right track. Let me print all the substrings of all lengths. There are two ways of doing it. The easy way of doing it, which is maybe not so useful, is as follows. So I go from length from 1 to the text length, and I call that other method. Let me just do it real quick so you can see what it does. All right. Okay. Also, what I've just done in the first couple of steps, you notice that I would right-click on it. Void. Public void. Compile again. All right. So I would right-click on it, and I would use this nifty feature of BlueJ that I can interactively make these. You know, after doing this a few times, that's probably getting a little tiresome because you have to enter that Mississippi string every time. So it probably is a good idea to start making myself a tester. What? Oh, it has dropped on? Oh, wow. So it does. Okay, well, then no, why bother with the tester yet? Oh, that's not the one that I wanted. I wanted this one. And here it prints all of the substrings. Looks good. But that is probably not entirely useful because I don't want to print the substrings. I want to do something with the substrings. So what I would kind of like to have is maybe a collection of all of the substrings. And that would actually be one somewhat potentially useful thing to do, to put them all into an array and then deal with them there. But I didn't think that's what you were going to do because we just started with arrays. What I thought you're going to do is you're going to do this. So I'm going to do something with all substrings, and that means I can't call another method. I have to put my action right here. At least that's how it is in good old Java.
Yeah, that was kind of part of what I wanted to do is figure out how to do it without arrays.
Right. No, there's no need to use arrays.
I was trying to do with arrays.
We'll do it with and without. So what I've just done is I've pasted the code here into here so that I have these two nested loops. I need to do a bit of an adjustment. I need to call this one n because that's what's called in the other loop. So let's do the n thing here. Let's clean it up. And now I don't want this. So now I have two loops. The outer loop says do something for all of the various possible lengths. The inner loop says do something for all substrings of that given length. And again, if it's possible to write this loop, this nested loop, if you think about it, by just thinking about it, but it seems easy and more natural for me to do it in this way where I develop it out of stuff that works. So this will now do the same thing. And now in this case, my do something is still to print it. We'll get rid of that in just a minute. But let's just do this one here. And now that I know that this is so easy. So now it prints them again. But as the fellow in the front row pointed out, that it's pretty useful to be able to do it in the opposite order. Why? Because we are not supposed to print all repeating substrings. We're supposed to print the longest repeating substring. And so if you try with the longer ones first, as soon as you find one that's repeating, then you can stop. So how do we get them from the longest to the shortest? Well, that's a standard thing. If you want to reverse a loop, then you switch the bounds here. So you say n starts at text.length. N is greater, equal 1, and n minus minus. Right, so you flip the bounds, you change the less equal to greater equal, and the plus plus to minus minus. And now you can see that it prints all the substrings in decreasing order. That's good. And now, actually, as was pointed out, that since the substrings are not supposed to be overlapping, we don't even have to look at the long ones. We only have to look at the ones that are up to a length of 2, because there couldn't possibly be a solution that's longer than that. Right? They're not supposed to be overlapping, so if you look at the picture, no, where's my picture? At this picture here. So this one here and this one here, together they can't be longer than text.length. Either one of them can't be longer than text of length over 2. Now in general, when you divide by 2, what do you have to be careful about? Well, when you divide by 2, you have to worry about what if it's an odd number and you lost 1. Right? Say the string has length 15, you divide by 2, that's 7, because it's an integer division, and 7 plus 7 is 14. In our case, that's fine, because the next bigger number, 8, would have been too long. 8 plus 8 is 16, and so that wouldn't have been a possible answer. So in our case, it's fine. But every time that you make an integer division by 2, you want to make that mental check to see if you've accidentally lost something. In this case, we didn't. All right, so now we can start saying, well, gosh, I don't want to print those strings anymore. What I really want to do with these strings, I want to check out if they are repeated, right? So now at this point, you have to say if text index of, what was it, sub stored plus n not equal minus 1. And that would be repeated. So and so here then it says that apparently the first one that was repeated was this one here. Is that the right answer, actually? No, you guys have done this, right? Did you do it with Mississippi? Did anyone get this far? No?
That's supposed to be the correct answer.
Okay, that was my question. Okay, I'm just trying to see if I need to spend valuable time checking on my code. So we're reasonably happy that this is our right answer. Okay, so now I don't want to print it. I want to return the answer. Right? I want to return a string. Also, at this point, I can start changing the method name to, what is it, find longest repeating substring. So I want to return a string. How do I do that?
Store it and check it.
There's actually a simpler way. All right, so I'm glad we're having this little chat here. When the test passes, what am I returning, the index or the string? The string, right? Let's double check. Yeah, with the string. All right. So the string is sub. I can just return it right here. And when I return out of a loop, then the function returns immediately, and any new loops that are still pending, they just die. And that's pretty nifty, because it means that if I find something inside a loop, if I find the answer, it's staring me right in the face, then I say, get me out of here, and here's the answer. So the fact that return returns immediately gives you the shortcut of just completely bailing out of a function as soon as you have the answer. It doesn't always work, but when it works great.
That was one of my problems. I kept putting the return statement on the outside.
Yeah, so and there's some programming languages where you have to do that, but as it turns out in Java, you can return from the middle of a loop. And because otherwise you have to figure out, since you wanted to find the leftmost longest one, then what if you find other matches, and then you'd have to guard against that. But here we don't. So let's compile that. Aha, it doesn't compile. Why not? Okay, let's do it again. It's a missing return statement. Why does it say missing return statement? I put in a return statement.
What happens if there's not a repeat?
What if it never matched? What if there wasn't a single repeating string? That could happen, right? If the word was, for example, non-repeating. That's not even true. Non-repeating has a repeating string, namely n. So, but there must be somewhere. Fred, right? If it was Fred, there would be nothing. And in that case, the loop would come, both those loops would come to termination at this point, and then we still have to return something. Now, what does it say? Aha, it doesn't say what we should return in this case.
Yeah, I had to check the test.
Expects null, okay. And so then that's where the null would come in. So the point that I wanted to make here is that the way that you can solve this kind of problems is if you find that it's too hard to engineer the whole thing in one fell swoop, is to do it a step at a time, to solve a related but easier problem. And so it's well worth figuring out what would be a pathway from the blank slate to the total solution that involves a step of easier problems. And if you can't envision the whole pathway, then that takes some amount of practice to map that out. If you can't envision that whole pathway, at least it's a good question to ask yourself or ask on Piazza, what is the simplest related problem that I should start with? And so here I kind of broke it down for you by saying, print substrings is a simpler problem that's along the same lines. And with print substrings, then what I just demonstrated is if that's too hard, you can even simplify that one to just say print the substrings of length 4, of a fixed length. So that's a great strategy to get going. There's some people who say that's a bad strategy because you should really be planning everything out in your mind first, and it leads to sloppy thinking when you do this kind of stuff. And it could. I've seen some students who, when they follow this incremental strategy, they just hack around the code until it somehow is beat into submission. And that's, of course, not so great either. So, but on the other hand, if you're completely lost and you start doing something, that teaches you so much about the problem that it really is worthwhile doing. So the right strategy is to iterate between thinking, coding, So whenever you've learned something new, step back, think a little about it, see what you learned, see what your next step should be, and having both of those in a mix really is the way to do it. All right, that's what I wanted to say about the homework. Let's see if one can use. Yeah, notice, by the way, no arrays, right? I wanted to say how I could have done it with arrays. So if you wanted to do it with arrays, you do it, let me go back to this, this point here. So I can find all of the matches here, and I could collect them in an array. So I could have an, oh, should I return an array or an array list? So let's remember the test of whether you should use an array or an array list. You use an array in one of three circumstances. If you know its length when you're creating it. So right now, do we know how many such matching substrings there are? We do not. Right? The second reason would be if it only contains numbers, while ours contains strings. And what was the third reason? If the instructor forced you to use an array. So the instructor didn't force, so we are free to use an array list. And that's the sensible thing to do here. So I have to make one. Yes. Is that the?
Don't you have to give it a name?
Yes, I do. Result seems like a good name. So over here, if I'm succeeding, then I can say result.add of the one that matched, and then I return result. Okay, so what this one here does is it returns all repeated substrings. And it doesn't print them, it returns them in a collection. Let's try that out. I didn't import array list. Very grateful for this tip. So, okay, now we're getting this result here. We can get it so that I can call, here's my array list, and I want to call toString on it. Okay, where the heck is toString? Just a sec. I'll do it again and I'll look at it.
ToString just above.
Oh yeah. Okay, and so let's see. That seems to make sense, right? So these are now the matching, the matching ones. So his question was, what is this weird arrow? This arrow here, I have no idea. It's supposed to indicate that it's an object reference, right? That it points to something, but it's just the artist's rendering of an object reference. So at this point, you could do inspect or get. This is actually a good segue. When I do inspect, then it shows me what goes on inside the object. It turns out that for array lists, that is not super useful. You could look at the element data and then inspect the element data. I guess that's okay. Then you can kind of see what goes on inside an array list. And notice, by the way, that an array list contains an array. It's a wrapper for an array, and it remembers how many elements are in there. This one apparently contains 12. It says a length of 15, so it has a little bit of extra room. And here you can see the elements followed by a few nulls in the unused positions. All right, so I'm not going to finish this, but now it would be easy enough to go from this solution to find the longest one. You simply pick out the first or the last one, depending on how you ordered it. But to collect all solutions like this is always a legitimate strategy. And so if people said on Piazza, use an array, they're almost right. A good strategy is to use an array list. Yes?
Are objects and arrays passed in return by reference or by copy?
Okay, everything in Java is passed by value. But what is passed by value? The reference is passed by value. Yes, so that means that in this case we're returning the array, right? So it's an array that was allocated on the heap, and we're returning a reference to that heap array. So if I'm guessing you're asking because you've done some C or C++ programming. Yes, in C or C++ this is what make you very nervous. But in Java it works fine. Yes.
Just so I get this straight, like when you do your comparison to make sure that there's no overlap, and you start from the end of the first substring you're comparing to.
Oh, I'll leave that to you to figure out. It was not my intent to solve the entire problem for you. What I wanted to show you is just some strategies on how you can deal with this. And so the two strategies that are useful whenever you need to process this kind of information is you could collect all matches, which is what I've just done, or you could bail out after the first match with a return that you saw previously. All right, now on to what I actually wanted to lecture about, which is the debugger. Yeah, so there was no pre-class reading. So what's a bug? We all know what a bug is. It's if our program doesn't behave the way that it's supposed to. The name bug supposedly comes from this creature here, from one of the very earliest computers that was ever built in 1945, I believe. And that thing was made out of electromechanical components, little switches that were pulled by magnets called relays. And apparently this moth was trapped in one of the relays so that it couldn't close, and the program misbehaved. And so that was the first bug. But actually the name bug must have been used for like technical glitches before that, because the person who kept the log wrote it down. She saved that thing as a joke. All right. So one way of finding bugs in your program is to use what's called a debugger. And a debugger will run your program a step at a time. Now you might say, why would I want to do this? And the reason is that it's less painful to do it than the traditional way. What most people do when they debug a program, that gets to have like this kind of complexity, and if it misbehaves, they start putting in print statements. And I bet some of you have done that you had a program that wasn't doing the right thing, you scratched your head, you posted on Piazza, no intelligent answer was forthcoming, and then you said, well, I'll just have it print out where I was. And so people might put in a print statement here that says, that prints start out here. And so when you do that, then all of the various starts are being printed out here, and you would say, okay, 0 to 9, 0 to 8, to 9, 10, and now at this point you would say, what? Right, because it's a lot of information. It's easy to get too much information quickly, but maybe we want to plus n equals, maybe we want to print star and n. Okay, so now I'm writing star and n interest of. I'll do it again. That looks a little better. And so now you could look at these numbers and see whether or not it's doing the right thing. And eventually you might find a pattern. In this case, it will do the right thing, so it's not much fun looking at the numbers. But eventually you might find some pattern that shows you that something wrong is happening, and then you fix some bug. And then what do you have to do? You have to take out the print statement, because you can't turn it in with the print statement. It would mess up the, the grading server. And so you've taken it out. Now what happens? You find your next bug, and you wish you hadn't taken it out. So I've seen people who leave all the print statements in until the very end, and then the debugging printout gets to be really complicated, and it's just a lot of stuff to look at, and so it's not so good. So debugging with print statements doesn't really scale up to anything that's larger than a few hundred lines of code. Most programs that are worth writing are longer than a few hundred lines of code. Yes?
Is the logger one useful?
Well, the logger is useful because you can activate and deactivate it better, but it's not a salvation either. At some point, your program's going to get complicated enough that you actually want to learn how to use the debugger. And so I distinctly remember when this happened to me. I was like 19 and I had a job as a coder, and there was a debugger available for the system, and I told my boss that we should buy it. My boss said, real programmers don't use a debugger. Real programmers read the hex dump. That was in the old days, when the way that you debugged the program is after it crashed, it printed out the contents of all memory locations in hexadecimal. And my boss was very good at looking at this thing. He would just glance at a page of gibberish numbers, and he would say, there, that's not right, fix it. And I wasn't that good, and so I bought the debugger with my own money, $300, I still remember. And my productivity instantly tripled, because I was able to get to those bugs so much more quickly than I was before. And so it was a great investment. So it will be a good investment of your time to learn the debugger. Debugger have gotten a lot simpler. The debugger in BlueJ is really, really super easy to use. So there's only a small number of concepts that you have to know. You have to know how to set a breakpoint, how to single step, and how to look at variables. So here's how you set a breakpoint. You click on the thing in the left, wherever it is that you would like the program or the debugger to stop so that you can look around. And let's say I want to stop each time that I reach this line here. Then I click in the corresponding column in here. Okay, fine, I have to compile it. And then it puts a little stop sign in here. I can have as many breakpoints as I like. I can put another one here. All right, so now that I have set the breakpoint, I can run my program. And you can run it the normal way, either by starting main in the tester, or by doing what we've done here, that we've just made ourselves a little bubble. So now I'll call this method here. All right, so now what happens is your program is stopped at this breakpoint here. And this display pops up that gives you some information about the program. So at this point here, it tells me the setting of the instance variables of my class, and there's only one, and that has Mississippi, which I knew it has. Not so interesting, maybe. I can see that n is 5. And I can ask myself, why 5? Yes, it started halfway through the length of the string, because over here it says text at length over 2. And so this is a super, super important point about using the debugger, that when you look around in the debugger, you have to have some idea of what you expect. When you try to debug a program that you haven't written yourself and you completely have no understanding of what that thing does, the debugger is probably not very helpful because you have no expectations. But when you wrote the program yourself, you had some expectations how often a loop would be traversed, what values it would produce, where it would stop, that kind of stuff. And what the debugger helps you is find mismatches between your expectations and what the program actually does. And it helps you find them faster than if you traced it through by hand or if you put in print statements. So you have to have some conception of what you want the program to do for the debugger to be useful. And that's a common mistake that people do. They have no idea what their program does. That has randomly copied something from Piazza. It doesn't work. They fire up the debugger. The debugger doesn't tell them anything, and they're disappointed. So the debugger really works for a program that you have created yourself, but that has some stupid error. It's off by 1 somewhere, and it crashes with, and it's just tedious to try to figure out yourself. Or it kind of puts spaces in the wrong place. I'm having a thing right now where I'm doing a thing for the exam, and it puts the spaces in the wrong place. And I futzed around with for about 5 minutes, and then I said, enough, I'll fire up the debugger. Yes?
Sometimes the error statement kind of points you in the right direction in a similar way to debugger.
Well, it is true that in a simple program, when it tells you that there was a string index out of bounds exception in line 15, then looking at line 15 many times will make it patently obvious what the error is. And of course, that should always be your first attempt.
Or you can kind of go.
Yeah, and so oftentimes when you go a little bit, you can get it. But trust me, as your programs get more complicated, as you have a few nested loops, a few nested method calls, you will quickly get to the point where you write code that looks perfectly correct and that produces slightly wrong answers. Just wrong enough that you're not going to get any credit for it. And in that case, you have to gauge what is the tipping point where it's worth firing up the debugger. Because firing up the debugger is not cost-free. I mean, A, you have to learn it. B, you have to get it started. You have to set some breakpoints. You have to step through it. It takes a bit of time. And I have been doing this for 30 years, and I can tell you, every time that I fired up the debugger and used it to find the bug in my code, afterwards I said, I should have done it sooner. Because it found the code usually the bugs usually fairly quickly and effectively. And so even I have a bit of a mental block of getting myself into debugging mode. It always seems to be a bit of a big step. And so it actually shouldn't be, and every time I tell myself to get going with a debugger, even sooner than last time, and I've never yet regretted it. I've never really found that a debugging session was a complete waste. All right, so right now you've already learned how to do 2 of 3 things that a debugger can do. You've learned how to set breakpoints. A breakpoint is simply a point where the program stops running when it hits it. And the second one is you've learned to inspect variables, because the BlueJ debugger makes that step completely automatic. It simply shows you all the variables, and you inspect them by moving your eyes towards one of them and reading off what it is. So there's no extra command involved for that. So now you get a few choices. You could continue at full speed. Let me do that. And then it continues until it hits the next breakpoint. Or you could step over, or what they just call step, versus step into. And so I could now just hit step, and then each time that I hit step, you can see the yellow bar moving to the next line of code. And eventually it'll jump out of that loop. Just doing it like this, it's not going to be very useful. I just want to give you a feel for what it does. So in this particular program here, I don't really have any method calls that are interesting enough to step into. So for that, I'll have to set up a different project, which I will in a minute. So one of the things that stepping is kind of useful for is if you just want to know how often was a loop executed. It might not have been executed enough. So I guess I should just set up that other program real quick. Yeah, and when you click on terminate, well, as you might imagine, it terminates the debugger.
Take out the breakpoints automatically.
That depends on the debugger. I think with BlueJ, it takes them out when you recompile. Some debuggers try to be very good, but keeping as many breakpoints as they can. Like Eclipse will try to keep them essentially forever, and that's pretty nice. No, that was not what I wanted. Okay, let me run this program for you so you can see what it does. It says enter a sentence ending in a period. And now it counts syllables, but as you can see, it doesn't really do a good job at it. And so now let's see what it actually does and if we can find a couple of bugs in this. Here's the word class. Well, let's look at syllable counter first to see that it doesn't do anything interesting. Syllable counter splits up the input into individual words, then it makes a word object out of each of them. It calls count syllables, it calls get text, and then it calls these syllables. Well, the get text seems to have been broken in some way, so let's find out what was the deal with that. So I could set a breakpoint into get text and see what happens. So, and actually I'm going to make another modification. Over here, it read the input from a humanly generated input, right? I had to type in the sentence, whatever it was. When I debug, I don't really like that. Why not? I've got to type it in over and over again, and it is not something that I enjoy doing. That's why I was happy to find that drop-down box. So here's the way that you can overcome that. Instead of system.in, you put in a string. Yes, you leave the scanner. That way you don't have to change any of your other program logic. Right? That scanner is already in place, and you don't want to mess with it so that you later have to put it back in. This way here, it'll read the characters of the string as if you had typed them. Now that alone was hopefully worth the price of admission today. Right, so now let's run this one here. Oh wow, it died? No, it didn't die. It landed at the breakpoint, and the breakpoint kicked us into the debugger. So now I can look at text, and at get text, when I can see that the text field is wrong, right? It should have been Mary, and somehow the Y got lost. So unfortunately, and this is the biggest limitation of a debugger cannot go back in time. It would be great if I could say, well, go backwards, so that I could exactly home in on where that happened. They're starting to build those debuggers now. So maybe in a few years, debuggers will in fact be able to go back in time. The difficulty is that going back in time is tough to do. And so what such a debugger has to do, it has to keep a record of every single change that the program ever made. And so usually they don't go back in time forever. But they now have debuggers that can go back in time for some amount of time, and that's nice. We're not there yet. So at this point, when you, there's no other remedy but to start again from scratch with an earlier breakpoint. So let's, yes, go away. Let's do it the other way around. Let's put a debugger breakpoint here. Oh. And run this. Now we're breaking inside main before the constructor has been entered. Well, the constructor is the one that sets that instance variable, so let's step into it. I click step into. Now we're out of main, and we're in the constructor body, as you can see here. So here the yellow line is where we are. We're in the constructor body. Okay, so here is some nasty loop. Let's see what it does. We can step over it. All right, now we can see what's I and j. I is 0, j is 3. And so now it's taking the substring from 0 to 3. Well, that's actually going to be mar because it only takes 3 characters. So now we need to say, what was this supposed to do? So while I is less than length and the ith character is not a letter, increment I. That's supposed to skip past any non-letters that I might have in a word. Why would I have non-letters in a word? Apostrophes, quotation marks, you know, what if it had been lamb in quotes like that, right? Then you'd want to get rid of those first. So that's what this code wants to do. So it skips past the non-letters at the beginning, then it skips past the non-letters at the end, and then it extracts the substring. So let's say what I becomes. I is the index of the first letter, and j is the index of the last letter. So what's wrong?
Your J is, that's not my
So let's draw a picture. Oh, that's another golden rule, that it is a federal crime, actually. And so you need to watch that out. It is a federal crime to use a debugger without having a sheet of paper next to you. You simply must have a sheet of paper next to you when you use the debugger. And so what I often do when I use the debugger, on that sheet of paper, I scribble down the values of some variables that seem to be weird or of interest. Or I make a little sketch. In this case, the sketch that I would make would be the following. So, okay, so that's my sketch. And now I'll look at the code here. And it's better with a piece of paper because you can see them both at the same time. So what's wrong with the code? Yeah, the problem is that j is the first one that's skipped. That's how substring works. So I have to put in a +1 here.
Or take the minus one off the declaration.
You're a brave man. What happens if you take off this -1? It'll break right here because it'll access a non-existing character. Yeah. Yeah, and that's also why coding by randomly adding and removing -1s is such a poor strategy because there are too many cases to consider. All right, so we did that. So let's try it again. Let's terminate the debugger and just run the tester. Okay, so it did retain the breakpoints, and now I kind of have the choice. Do I want to erase them? I'll leave them in for now. And, well, now I get a no such element exception. Maybe I didn't enter a sentence that ended in a period. That's exactly right. Okay, but let's look at my output. Oh, I don't have any output. Okay, now it had it's good, except here this doesn't look right.
And Mary also.
Oh, and Mary, yeah, yeah, okay. So, and unfortunately this is computer science, so we don't really get partial credit for getting the right answer in 3 out of 5. So let's see what the bug with that might be. So at this point we need to figure out how it counts those syllables. That's the code that's over here. Ugh. Okay, fortunately our very first test case fails with Mary, so it's probably worth setting a breakpoint here and seeing what happens. All right, so we'll step count is 0, end is 3. Now we're inside Mary. An E at the end of the word doesn't count as a vowel. Okay, so, but that's not the situation. We have a Y at the end. Inside vowel group is false. At this point, we probably have to start actually understanding this code. That's too bad. So we have a Boolean flag that says currently inside a vowel group. We're looking at all of the characters until the end, where the end is either the actual end, or if the word ended in an E, we don't count that as a syllable. There must be a reason for it. I guess it's a mute E, right? If the word is mute, for example, ends in an E, and you don't want to count that.
This actually needs to be way more complicated. You really need to separate.
Well, it's there to demonstrate the debugger. Here we're checking if the text is a vowel, so we're turning into lowercase. We're checking whether it's inside A, E, I, O, U, Y. And if it is, then it's a vowel. And then we're incrementing the counter here. Where are we even? So this should be happening when we see the Y of Mary. Step a little bit. Oh, it's in fact going to be, no, when we see the A, that's happening right now. Now our count is 1. So let's see what happens. Now we have our Y. You can see that it's the Y. You have to look carefully for that. So that's the Y that I want to get counted. Okay, now watch carefully. It's a vowel. We're inside this loop. We had detected that the Y is a vowel. So now it should increment the counter. It didn't. So it did not step inside this loop. Now, if you didn't have any particular expectation, the debugger would be useless. If you had the expectation that the Y was the start of a new vowel group, then you knew it was supposed to go in here, and now you can ask yourself, well, why didn't it? Well, it didn't. Let's look at inside vowel group. And inside vowel group is true. That doesn't make any sense because we are looking at the string Mary. Previously we looked at the R, clearly not inside a vowel group. And now we're looking at inside the Y. And so we're just starting a vowel group. So we should be getting into here, incrementing our count, and saying, oh yeah, by the way, we're also in a vowel group. Why didn't it do it? Yeah, it seems to never have set it to false, right? So I guess what we should have said is, if it's not a vowel, well, at the very beginning it's false, then it got set to true by the first vowel group, and then it never got turned off again. So let's try that. So you have to redo everything after you compile. There's some debuggers that are able to hot swap in changes in the code. Eclipse in particular is very good at that. So you can debug, you can make small changes to your code, and as long as the changes are not too large, it'll actually inject them into your running program, and then your program continues with the changes. That may or may not be good. Sometimes it's very difficult to keep in your mind what that actually does, but when it works, then it really is a nice feature. All right, so now we're good. Mary has 2 syllables. Now little, well, that's kind of not a flaw of the program, it's a flaw of our algorithm of dropping that last E. And I guess if you, maybe little, if you pronounce it like that, only has 1 syllable. I don't know. But that did fix the 2 bugs in our program using this magical tool. So I can't really assign a programming homework with it, but I really, really want everyone to use it. And so I'm doing the next best thing. I'm checking that you are learning to use it on the exam. So there will be an exam question that says, run the debugger until a particular point. Tell me what's in these variables. Now hit step into twice and step over 3 times. Now you're going to get to this point. Which line are you at? That kind of stuff. So if you are a quick learner, do absolutely nothing and start learning it during the exam. Otherwise, you know what to do. All right. Thank you very much. Oh, there's one final thing. Just a heads up. I hope this won't happen, but next Wednesday, I'm actually not here. I'm at the dental surgeon, unfortunately, and I'm going to try to get someone to give the lecture. If I'm not succeeding, I will have to move the exam by 5 days. So I'm hoping that's not happening because someone might have travel plans or whatever. I'm just giving you a heads up, it might happen.